Hello and welcome to CodeWord. I am Samvid Mistry and this is From Rusty to Rust. Now before jumping into the language and syntax, I'd like to take a few minutes and discuss why we needed a better system programming language and also criticize some of our favorite languages while doing so. So when I was doing my research for this video, I came across a really great and amusing article which is linked in the description. The article uses an analogy to describe how our current system programming languages such as C and C++ behave while executing code. So the article says, imagine you are a construction worker and your boss calls you. Here's the boss. Hey Bob. Yes boss. I want you to connect the gas pipe in the basement to the street's gas main. So now you go downstairs and find a glitch. The house does not have a basement. So what do? You probably do nothing, or perhaps you decide to have a little fun and attach the gas main to some other nearby fixture, probably the neighbor's air intake. Either way, suppose you report back to your boss that you are done, and eventually you get fireworks. You might be laughing right now thinking that's ridiculous. Nobody's dumb enough to do something like that. I hate to disappoint you, but our system programming languages are. In C and C++, the programmer writes syntax like the one present on the screen, which is confusing for even the experienced developer sometime. And the language goes on to interpret the instruction, casting stuff around and going through memory unrestrictedly, assuming things, and then ending up at a place where the programmer didn't even thought the program could reach. Now, I'm not an expert in this matter, but in my opinion, the problem is with the amount of flexibility provided by the language with poor choice of syntactical representation. Some other arguments given in the article are mainly academic, so we'll just go over them pretty quickly. So understanding what C or C++ program do requires additional, reasonably detailed knowledge of how the computer's memory system works. For example, stack versus heap and word alignments, etc. This, by definition, is low-level. High-level languages such as Mathematica, Java, Scheme, and Python lets you focus on computing an answer rather than on the details of how a language might implement your program. In initial years of learning about programming, the focus of learning should be on how to make students think about problems algorithmically and solve problems by writing simple programs which almost look like a pseudocode. Manual memory management isn't what goes into the starter pack of a student just starting to learn his first coding language. Now, moving our focus to real-world development using C or C++ as a language, when I start writing programs in real world, everything seems fine on our machine while coding and testing the program. But sooner or later, when the same program is run on other machines and platforms and other operating systems, we hit a wall called undefined behavior, which gives rise to famous programmer quotes such as, "It works on my machine." What works perfectly in Linux might do something completely unexpected on Windows and vice versa, because the platform on which you are writing your program affects how you write the program. For example, on Windows you have convenient Konya.h, while in Linux you have no inbuilt alternative. Also, C language was designed very long ago and we have learned so many things since then. The language itself has many loopholes which you might not be aware of. Many features and behaviors in the language were there solely because it allowed reuse of existing code or was easy to implement, regardless of how it would confuse the programmer. If you are interested in learning more deeply about the history of C language and how the language behaves under the hood, you can read this book called Expert C Programming by Peter Van Der. I'm linking it in the description below. The book contains many stories on how the language behaves weirdly and how the known bugs in the language are not fixed and probably will never be fixed, mainly to avoid breaking a lot of legacy code which depends on these kind of unexpected behaviors. An example of it would be that use of const keyword does not really make the variable constant. It just tells the compiler that this variable should not be used in the assignment. The variable can be used to change the value by other means. I think this is enough rant about how we need an upgrade in the world of system programming. Realizing these things, people made Rust. According to the Rust language website, Rust is a system programming language that runs blazingly fast, prevents segfaults, and guarantees thread safety. Here, I'm assuming that you know the basics of programming languages and are comfortable with the basic words such as variable, function calls, and macros. So let's write our first Rust program. I'm not going to cover the installation of Rust compiler because it is literally only single command which you can find on the Rust language site. I'll link it in the description below. So we are in our good old VideoWorks directory. Now let's make a directory, mkdir rust underscore projects. Let's go into the project folder. Now vim rust.rs. Yes, the extension for the Rust program files are .rs. Let's open up the program, and I'm going to write a simple program here, and then we'll come back to examine the program. fn main println hello world. This is the ritual made famous by our own Dennis Ritchie. We'll save the file. Let's just first compile it and see if it works. So Rust compiler goes with the command rustc, and we give the file name. It compiles the program. Hopefully it will compile error free. Okay, it's done. And we see our executable .rust. Running the Rust, we see hello world. Now coming back to the program, many things should seem familiar to you if you have learned any other imperative programming language. fn is mainly used to declare a function. Execution of our program starts from main function. Here we are using println for printing. You might notice the exclamation mark after println, and no, it is not what you think it is. We don't have to append an exclamation mark after every function call. Exclamation mark tells the language that this is not a function call but a macro call, and this is supposed to be replaced by a lot of code which is actually used to print the statement, and it is replaced by the compiler. Now println is a macro in Rust. The parameter here is a string which gets printed on the screen. Now we will focus on the language features in future videos, as we have made it pretty clear why we should learn Rust. See you next time. If you liked the video, please hit the thumbs up button, subscribe to my channel, and share this video to all of your friends. Peace.